activity for. The V question asks, what effect does adding a second 3-cell battery have on an already charged capacitor? So if we consider the 3 diagrams across the top, circuit A is a 3-cell battery pack with 2 round bulbs and a capacitor, and it says circuit A, the capacitor begins charging. Circuit B, capacitor is charging, is complete. So basically A is the beginning of charging the capacitor, and B, now the capacitor is fully charged. You can see that because the top plate has an excess of charge and the bottom plate has a deficiency charge. But the big question here is, what happens to an already charged capacitor if we add a second 3-cell battery pack to that already charged capacitor? Down here it says circuit C 20 seconds after adding a second 3-cell battery pack to the charging circuit. One thing I'd like to ask is, does it look like this second 3-cell battery pack that we've added, is it facing in the same direction or a different direction than the original 3-cell battery pack? Well, our original 3-cell battery pack had the positive terminal, or the longest line, up top, and the shortest line, or negative terminal, blue bolt, down on the bottom. And it appears as though the second 3-cell battery pack is facing in the same direction. We'll have to be careful to do that when we set things up later. So under our predictions, it says draw error tails and bulb rays on circuits A and C, include initial bulb brightness, bulb lighting time, and the direction and degree of compass deflection. Now, it suggests that we're supposed to do this for A and C for starters, but how about if we make our predictions for A, and then we'll test A, and then we'll make the predictions for C. So at this time, pause the video and draw bulb rays and arrow tails on circuit A, and put down what your predictions are for initial bulb brightness, lighting time, and degree and magnitude of compass deflection, and then unpause the video and check those out with the results once you've made your predictions. Now that you've made those predictions for circuit A, let's test those out before you make your predictions for circuit C. So we start here, we've got a 3-cell battery pack and 2 round bulbs in a loop. And we're just going to make sure that we've got a nice closed loop here before we put the capacitor in there. And the bulb's light, so we know we have a closed loop. And notice on the capacitor here, I'm going to note that there is a plus sign next to one terminal and a negative sign next to the other terminal. Now we know that a reset capacitor has the same amount of charge on both plates, but this way it can at least keep track of which side of the terminal we're adding the wires to. So I'm going to go ahead and put the wires coming off the red springs to the positive sign or top plate, and hook the negative terminal up to that. And then we just saw bulb brightness and lighting time. And if you check out the compass deflection over there, we can check it one more time if you like. We can look at the magnitude of compass deflection when that deflects. And checking it out, and focus that in a little bit, and go. And it looks like it's about 20-degree clockwise compass deflection. So please record this data under your observations. We've got a lighting time of a little less than 1 second. We had just about 20-degree clockwise compass deflection. It might have been about 18 to 20-degree compass deflection, and the bulbs were bright, just like a 3-cell battery pack and 2 round bulbs in the loop. So probably 3 bulb rays and 3 arrow tails. And this, it's not frozen. Okay, so please pause the video at this time and make your predictions for circuit C. Welcome back. Now that you've made your predictions for circuit C, we're going to see what happens when we add a second 3-cell battery pack to an already charged capacitor. So we had previously charged the capacitor, right? Now we're going to make sure that this battery pack is facing the same direction. The red springs were up top, blue bolt down below, and we're going to set this up the same way. We're going to go ahead and pull this wire back here, and we're going to hook the red springs for our second battery pack to the blue bolt of our first battery pack, and then the wire that was on the bottom part of the loop Sorry about that. And then we're going to go ahead and hook this up, and watching for lighting time, bulb brightness, and compass deflection. Ready and go. Now, if you notice, the bulb brightness and lighting time was about exactly the same. And then as far as compass deflection goes, that's a little bit tougher to see. It was about 18 degrees clockwise, but I'm going to go ahead and reset the capacitor. We're going to charge the capacitor with the 3-cell battery pack. And then we're going to go ahead and bring the compass closer. And this is when adding the second 3-cell battery pack to the already charged capacitor. And again, we had just about a 20-degree clockwise compass deflection. At this time, I'd like you to pause the video and write down a claim evidence reasoning based on what you've seen so far. And if you had additional questions for me about things that we could do with this, you could come back and ask. Please pause the video, claim evidence reasoning. Now that you've come back from your first set of claim evidence reasoning, I asked the other students to do this, and some students asked, Mr. Locks, could we discharge the capacitor? And I said, into what? And some people asked about bulbs, and some people talked about discharging into the Genicon. And so we went ahead and discharged the capacitor. All right, we reset the capacitor, and we're going to go ahead and charge the capacitor with just the 3-cell battery pack for starters. Ready? And we set it up that way, and we're going to discharge this blue capacitor into the Genicon. So we got red to the positive. Go ahead and set this up in here, and you guys can count the number of turns. Ready, go. And that's about 3/4 of a turn. So it's been consistently between 1/2 and 3/4 of a turn. So around 2/3 of a turn. This one was about 3/4 of a turn. So now I'm going to pull the Genicon away. We're going to go ahead and charge that capacitor with one 3-cell battery pack, like we did before. Ready, and bulbs lit. The compass deflection was 20 degrees clockwise again. Now we're going to add a second 3-cell battery pack face in the same way to the already charged capacitor. Ready, go. And again, the lighting time and compass deflection was the same, but now we're going to discharge the capacitor into the Genicon. I'm going to take the movable handle and put it back to the clear stationary handle. And we're going to count the turns. Ready, 2, 3. It's about 3 1/3 turns. So the capacitor that had been charged with a 3-cell battery pack and then a second 3-cell battery pack added to it obviously was able to turn the Genicon handle many more times than with just one, when we charge it with one 3-cell battery pack. So based on that, what new claim evidence reasonings can you make?